It's about to start, we'll talk about code or whatever we'll talk about today. It's about to start, so please hang tight while I check that everything is okay. Sound, check. Camera, check. Lights, check. How's my hair? Oh, wait, I don't have any hair. Maybe put some pants on and I am good to go. So get ready wherever you are, 'cause this stream is about to start. Get ready wherever you are, 'cause this stream is about to start. Hi, my name is Leandro Facchinetti, and let's write some code together, shall we? It has been a while since I said this. We have been off for a while. I have recovered, almost entirely. I'm still not 100% back, but I am better. And I'm happy to be back. Anyway, let's get into today's topic. What we have on the menu today is the Data Bender project. In case you're new here, data bending is this process in which you take a media file, so think of a video, for example, and you process the bytes that make up that video as if those bytes were audio. So you put a phaser, you put an equalizer, a compressor, something like that in a video file. And the results tend to be glitchy and interesting and unexpected. So it is a kind of a visual art form kind of thing. And naturally you can do the opposite. You can take an audio file and process it as if it was video. So you can do a Gaussian blur, for instance, on audio. The results tend to be glitchy and weird. And you can really data bend with any kind of media, processing it as if it was any other kind of media. The tricky part of doing this is that you want to make sure that you end up with a file that makes sense, that is not corrupted, because if you just take an arbitrary stream of bytes and try to read that as a video or audio file, most likely you won't be able to, because there are some headers, some metadata, some information that comes along with the media, and that will be invalid. For instance, a piece of metadata could say, what is the size of the file? And that piece of metadata could be a negative number. A negative size doesn't really make sense. So a file like that would not be processed correctly. So in the process of data bending, we have explored in a series of streams all the potential mistakes, and we found a way that works. And now we are writing a program that encapsulates all this knowledge and presents a relatively straightforward interface to the user. So if you are a person doing data bends and you want to data bend a file, you throw the file into the program and you're going to get a bunch of data bends out, and you can work through them and see if you like the results. So specifically what we're going to be doing on the project today is, number one, the files that we have for testing are huge. We'll need to make them smaller. I'll show you in a minute. Second, there is a glitch that prevents some video files from being opened in QuickTime and most other video players, in fact. We'll look into that as well. It has to do with pixel formats. It's kind of interesting. Then we will experiment with more data bends. Currently, we only have a placeholder. We will have more ways of data bending to have more interesting results. And then lastly, we will try and loop our program in a way that will produce not only one data bend, but multiple. Oh, look at that, Mage is here. Thanks for joining us. It has been a while. I'm glad that you're here, and I hope you enjoyed the show. Let's get into it. First of all, if you are a very careful follower of the channel, you may have noticed that when I published this to GitHub, which by the way, if you are interested in looking at the code, you can always go to my GitHub repository for this. But in the examples folder, you may have noticed that I didn't put anything there. I tried to. So last time we worked on this project, we came up with 4 test files, 2 video files, 2 audio files. And then I committed these files and I tried to push. And I thought it would work, but it didn't. And I was surprised by that. The files are relatively large, but not that much. We are talking about 20 megabytes. And I thought that Git and GitHub would handle files of this size just fine. Once you get past, let's say 50 megabytes or something like that, I would expect that you would need the, what is it? I think it's Git LFS for Git large file system or something like that. So once you get past a certain file size, you do need to go to these other extensions and use some other tools. But something of this magnitude, I was not expecting to fail, but it did. When I pushed, I didn't even get a good error message. I pushed, I got to almost the end of the process of pushing. When you git push, you will see a bunch of messages. I got almost all of them, but the process hanging there, and I was never able to see the contents here because the files were too big. I didn't even get a good error message. That was particularly frustrating. But anyway, what I did to solve this is, it was the nuclear approach. I could have gone with something. Hang on, before I explain the solution, let me explain the problem. I wanted to remove these files from the Git repository, and I could not simply remove the files and commit, because once you do that, you're just adding to an existing history, and the history already has those files in there. That's what Git does. It keeps track of history. So if I just deleted the files and committed, that would not work because the files were already in the Git history, and the push would fail. So that is the problem. There are tools to rewrite the Git history and do arbitrary things. For instance, remove files or remove anything that was touched by a certain person or anything like that. You can filter the history using Git. But that was too heavy-handed. The history of this project was almost non-existent, and I don't really care too much about the history of projects anyway. I don't, for instance, write good commit messages because for the most part, I'm just iterating on an idea. When a project gets a certain size, you do need to be more organized about managing pull requests and commit messages and so on. But this is mostly a prototype, so we don't need any of that. So instead of trying to filter the Git history, I went with a nuclear approach, deleted the whole .git directory, which is where Git keeps track of. Oh, not that. So yeah, Git keeps its database, the history of your project, under this folder. I deleted that folder and started a new history. And in that one, I did not push or did not commit these 4 files. So now we are in this situation where we have these 4 files that are too large for Git. And to be honest, they were also too large for data bending because we were data bending the short file and it was already taking too long for my taste. So today, the first thing we'll do is downsample these files so that they are smaller, both for Git's benefit as well as for the performance of the data bending as we test things out. So we have 2 video files here. The short video file is relatively short. It's only 7 seconds, but it is a large file in terms of dimensions. It is full HD. We are going to maybe do 460p or something. We'll do a smaller thing. And it is not showing here, but it is at 25 frames per second. We'll do probably 5 frames per second. And this file will go down in size. And what are we going to use to do this? Of course, ffmpeg. The input file will be, let me go into the examples folder. And video short is the input file. The output file will be video short small. and we will set the rate to be 5 frames per second, the size to be let's do half of this. So what is this divided by 2? 960. And what is that divided by 2? $540. So it's not 460p, it's going to be 540p. Do we need to change something else? I don't think so. Let's try this. Okay, something got out of here. Let's look at the metadata for the output. It is only one stream. This is the good codec that we want to use. This is a good pixel format. This is the size. This is the frame rate. And we could go further into this and look at the bit rate, but we may not have to. Let's see if the file size is acceptable. Yeah, half a megabyte is perfectly fine. Let's see what this file looks like, and it's only video, so I don't have to put my headphones on. Correct. Yep, that's perfect. So we can get rid of the big file and rename just like that. For the long file, it's going to be about 5 times that size, but I think it should be okay. It's going to be a 5 times 600 kilobytes, so it's going to be around 3 megabytes. But I think that Git can handle that much. It should be able to. We'll see. Aria is here. Yeah, no one reads them anyway. Reads what? Hey, Aria. Nice to see you here. And Not Was One is here. Hey, what's up? Thanks for joining us. I hope you enjoyed this session today. Let's do the conversion of the long file. Yeah, it's about 2 megabytes. Git should be able to do that. Let's delete that. And then this long audio file perhaps needs to be downscaled as well. It is using 24 bits per sample, which is a bit much. And this one is using 24 bits per sample as well. So I do want to keep the sample rate, but I will reduce the number of bits per sample. That should improve on things. So the input file this time is going to be audio short. I'm going to apply the same processing to both just because we will have a more standard thing to work with, even though it could be interesting to look at different kinds of files, but we'll do that later. So for audio, what I want to do is simply to change the bit depth. But unfortunately, I forget how to specify the bit depth. I forget the magic command line flag. Maybe in our cheat sheet we have something like that. Well, when you're converting audio to raw audio, this is the sampling rate, this is the number of channels, this is us doing a filter in ffmpeg, we'll get to that later. Yeah, we are only specifying the bit rate and the number of channels, the sample rate and the number of channels, not the bit depth. So let's look at the help for ffmpeg. and see if we can have access to this parameter. Quality, frames, rate, number of channels. Crud. I think I will have to resort to the documentation. Oh no. Come on. It's either going to be here, the documentation for ffmpeg itself, or it's going to be here, the documentation for the wave codec. Sorry, raw audio codec. Well, it's kind of a wave codec, but not really. It appears that it doesn't treat that bit depth as bit depth. Maybe they use another term of art for this. Audio options. This is sample rate. This is the quality, number of channels. Sample format. There you go. That's what we need. It doesn't call it bit depth. It calls it a sample format because it puts together the type of representation. So are you using linear PCM? Are you using mu law? It puts that along with the bit depth all in one. So that's why it calls it the sample format, which I guess is also consistent with the pixel format when you're doing video stuff. So now let's see what are the sample formats we have available to us. Oh, I should use this flag to see the options. And let's filter for PCM. Why are you doing this to me? The depth of 16 should be good. But really, I think that the way I should be doing this is by using something like this, by specifying a format. So I'll specify an audio format of PCM as 16 little endian. No such filter. Oh, not audio format. This stands for audio filter. How do I specify the format again? Just -f. It's not a suitable output format. Unsigned 16-bit little endian. That's the format. Yeah, that's all right. All right, we got this. So the short small, it is smaller, but it's not small. And for whatever reason, Finder cannot show me the metadata. Well, let's ffmpeg the audio short small. Ooh, invalid data found when processing input. Did ffmpeg create a WAV file that is invalid? Seems like it. Great stuff. Bo is here. Hey Bo, what's up? You feel embarrassed for me? Why? Or do you feel embarrassed for someone else? What is embarrassing? It appears that this is an invalid file that I produced. I wish that ffmpeg would help me with these kinds of things. No error messages, no nothing. That's too bad. Let's leave the audio for later. Because we are focusing on video for the time being. So let's try and commit and push. Wait a second. Visual Studio Code recently added the feature of playing MP4s because it's browser-based, right? Visual Studio Code is browser-based, and browsers can do video, so you can play video, and that I already knew. But are you telling me that it can also GIF videos? I mean, in this case, it's kind of trivial because there was no video and now there is a video, so that's okay. But if I do a change to the video, will it pick it up? Because that's amazing. I'm totally in for that. It could like find sections of the video that are the same. But given the way the video is encoded, that sounds like an impossible task. Anyhow, let's see if we can push this. It's such a small file. It should go. Yes, it is there now. Awesome. Finally, if you go to this, here are our video files. Awesome. But I will have to remember to not push these guys or not commit these guys because they are too large. Well, I will do my best. So task number 1, smaller test files, done. Task number 2, explicit file for pixel formats. What's going on here is I was producing some files that were valid. I knew they were valid because VLC would play the files. But Finder, the preview thing here, would not play them. QuickTime would not play the files. I found that Safari wouldn't play the files, so perhaps it is a macOS problem. But I read online that many other video players have the same problem, and the problem has to do with an interaction between the codec and the pixel format. Using the H.264 codec for video, most video players, VLC and Reaper are notable exceptions here. VLC and Reaper could play files that I threw at them, almost all files I could throw at them, which is not surprising because VLC can play pretty much anything, and Reaper decodes video using VLC and other options if they are available. But in that case, I think it was using VLC. So if VLC can play a file, Reaper can edit the file. Anyhow, the problem is most video players cannot deal with codecs, with the H.264 codec if the pixel format is not YUV420p. Now, I could perhaps just force that pixel format on the output, but I think what we should do instead is respect the pixel format of the input. Because the way that we are transforming things is we get a video file, we convert that into a raw stream of colors, in this case, a raw stream of bytes representing colors. We do audio processing on that. Then we convert back into video, encoded video, and for the most part, we respect the inputs. So if the input was an MP4, the output is going to be an MP4. If the input is an MKV, the output will be an MKV. If the input was full HD, the output will be full HD. But in our code, we were not explicit about the pixel format. So that's what's up next. Before I do that though, let's see if I can reproduce the error to show you the error real quick. So let me remember how I actually run this project. It's just npm start, and it's going to be working on video short. Oh no, there is already a problem. No such filter M. Wait, what? Let's go to the log and see what it tried to run. Yep, we produced a format that is not so good. What is up with that? The audio filter was just the letter M. Oh, I know what's going on. That's what's going on. Never mind that. Something I changed off camera after the last stream is I had all these variables extracted. They were like below here, and I put them in line because we will be changing this so fast and so often, and there will be more complicated rules that govern how we do these things as we learn more about data bands that we like or dislike. So I just inlined the whole thing, and when doing that, I forgot to put the square brackets that represent list. So low dash sample was trying to sample a letter out of the word tremolo. It happened to sample the letter M. But what I really want is a list to sample the word tremolo from that. That's what's up. I'm now rerunning, and we do get an output. It doesn't break this time. Good. But let's see if QuickTime will be able to play that. Yeah, judging by the fact that Finder didn't play it, I think that play it. Yeah, so this document couldn't be opened. It is a valid file, though. I will prove that. See? And this, by the way, is the result of applying the tremolo audio effect to video. Fun stuff, huh? So it is a valid file, but the pixel format of this file is probably going to be UV444, if I understand things right. Yes, YUV444. That is a format that QuickTime will not be able to handle. So what we should do is respect the pixel format of, as you can see, the input file is YUV444. Hang on, where is it? Codec details. Well, it doesn't show here in VLC. Isn't that fun? Or is it showing and I'm being silly? No, it's not showing. FF Pro off video short. .mp4. Yeah, the input was YUV420p, but the output became YUV444p. And I think that it kind of makes sense that ffmpeg does that, because we are not informing the pixel format we want, and ffmpeg is producing the pixel format that will preserve the quality to the best of its ability. So it's not losing information in the encoding of the pixels, which is good if you are thinking about quality of the video, but we are more interested in compatibility, I think. And I guess more than that, we are interested in not modifying these underlying properties of the file unless we really have to. And the reason for that is that you probably don't want to have files that you could play with QuickTime and now you banned and you cannot play them anymore. That could be kind of tricky because you would have to learn about what's going on. And not having to learn what's going on is exactly the purpose of this tool. It is to help people who don't want to get that deep into all this technical stuff. So to do that, what we are going to do is get rid of that for the time being, come back to the source and we will go to this place here where we are parsing the metadata in a line that looks just like this. We are parsing that metadata, and right now we are extracting information about the dimensions, width and height, and we are extracting the frame rate, which is this part. But what we are not doing is extracting the pixel format. And unfortunately, for things like frames per second, it says it right here, frames per second. So the frame rate is rather straightforward to find. But this may not be so straightforward to find, which is unfortunate. We will have to play with a variety of files to see how stable this format is, because the format that we are looking at here is a human readable format that you are not supposed to be reading programmatically. So we are kind of hacking this. And the reason why we have to hack this is because I don't want to ship ffmpeg, which would be able to give me a standard format, a JSON format, for instance. I could use ffmpeg for that, but then I would have to ship ffmpeg, which would make the binary bigger later down the line. So I'm not interested in that. Instead, let's just read this line. And so we have the stream right in the beginning, and then we have this information, and then we have video, and then we will have the codec. Maybe we should be explicit about the codec as well. I think we'll do that, yes. So let's capture this. We're going to do a capturing group called codec. Is this what ffmpeg calls this, a codec? I think it is. This will be anything that is not a space a bunch of times, then a space, and then a bunch of things, and then a comma, and then a space, and then the pixel format. So we will do a capturing group called pixel format. And that one will be letters and numbers, one or more of them. And I cannot put a space here because we have this parenthesis. Then we have another comma, and we have here the what is this called? The bit rate. Perhaps we should preserve that as well. Is the bit rate of the input the same as the output? Probably not, because we're not doing anything about this. So if I ffmpeg the input, the bit rate was 640. But the output is much higher. Yeah, let's be explicit about the bit rate as well. And I wanted to be explicit about these things, but I don't know what they are. TBR and TBN. Oh, I hate these abbreviations. Let's see what you are saying. For having to read the manual. Yeah, it is embarrassing to have to read the manual, isn't it? Hey, unrelated question. What OS version are you on? If I open this, is it going to show the serial number? Hang on. It will show the serial number. So how do I see the version of macOS without looking at the serial number? Oh, I have it here. So Arya, the answer to your question is this. I am on macOS Ventura 13.01, and this is the build number. There you have it. I sometimes wish that I would play around with these kinds of retro computers, because I'm into retro gaming, and I think that retro computing could be kind of fun. I think bitrate would change, no? Since the number of static frames changes as you bench. Oh, what you're bringing up is kind of interesting. All the data bands that we played with so far are preserve the length of the video. All the data bands we worked with so far, they have the same number of bytes as inputs and outputs. But it is true that some data bands could extend the video or even contract the video, so the length of the video could change. But even if the length of the video changes, the bitrate could be preserved, because the bitrate is just how many bits are you using per second. It doesn't matter if it is 5 seconds or 10 seconds. So I think we should be preserving the bitrate, and I don't think that the bands are going to change the bitrate. That's what I think anyway. Yeah, and if you all know what TBR and TBN are, I am happy to preserve these values as well. Okay, so input metadata. Let's see. We have stream, blah. We don't care about this. Then video. Then the codec. Hang on, I want to take a moment to see if codec is the right name for the thing that I'm going for here. ffmpeg help. And I want to say that this is a codec, but let's ffmpeg codecs, and if I am right, then age 264 is going to be listed here, and it is, so I am right. So that's the codec. Next, let's look. The thing in parentheses we can ignore. Oh, hang on, I am missing this, so that we ignore that stuff. And let's see the codecs again. I think that all the codecs are letters, numbers, and underscores. So they should match this. Because the W matches underscores as well, am I right? If I had a codec like this and tried to match with a regular expression that is like that, yeah, it matches. Very convenient. Then for the pixel formats, we need to list the pixel formats. And they are just letters and numbers and underscores as well. Very convenient. Then width and height. Then hang on, why do we have this space here? There is no space there. How come this matches? That's odd. Whatever. Then we will have here a capturing group called bitrate. And that will be just numbers, and then space, and then dash, then comma, space, frame rate. Can the bit rate be fractional? I don't know, just in case. I think I'm gonna rewrite this actually. I'm just gonna say that it can either be digits or a dot, and I'm gonna do the same for the other one, in case you have a fractional bit rate. Okay, I think I got this, but just to be sure, no, we did not get it. God damn it. Back then it was cooperative, cooperative OS, no preemptive multitasking. Right, yeah, I am watching that series of videos by the coding train. And Dan is working with the Apple too, so you get a taste of that. It's kind of fun. TB is time base, but I don't know what R and N are. Oh, good to know. Time base. The time base in AV stream that has come from the container. Ah, interesting. And TBC is the time base in AV codec context for the codec used for a particular stream. TBR equals TBR is guessed from the video stream and is the value users want to see when they look for the video frame rate. Oh, thanks for doing that research for me. So is this something that we want to preserve? If we can provide this when producing the video, probably yeah. Probably yeah. But I'm gonna leave this as a to-do. But now, why is this failing? When working with regular expressions, often things don't work first try. So let's iterate on this real quick. We have a copy, so I don't lose what's there. And on this terminal, input metadata is already a line we got from ffmpeg, this line. So let's do this step by step like so. Oh, already? That's odd. What's wrong with this regular expression? I cannot see the mistake. Are you for real? Can you even find the word streaming there? Unexpected token? What the hell? Okay, you can find the word stream in there. Can you find this garbage in the beginning that we don't care about? Null? What the hell? This is multi-line stuff. And this part was working before, so what's up with that? God damn it. I can do this, I guess, and work from there. That matches. So the problem really was the beginning. If I ask for a bunch of spaces, you're gonna allow me, right? It's just a bunch of spaces. Get out of here. Okay. And if I do beginning of line, because I am in multi-line mode, that should match. But it doesn't. Is it because I don't have enough Like I don't have lines above this? Could that be the case? In reality, we will have other lines above, and then our line will be like in a random place, and there will be random stuff above and below. Now it works. Okay. I will not pretend that I understand why this isn't matching, given that I am in multi-line mode, but I will take it. So let's just double check that we got all the groups right. Codec, that looks like a codec. Pixel format looks like a pixel format. Width and height look like width and height. Bit rate is correct, and frame rate is correct. This is very fragile though. I'm pretty sure that there will be some video formats or pixel formats that will not work with this regular expression, but whatever. We'll get to them when we get to them. So now that we captured this information, we can list it here. And I think I'm gonna change this to just be like, this is gonna be the input metadata text. This is going to be the input metadata match. And then this will be the input metadata, just like that. And then a bunch of things are going to ask for that. And that's all. But now that we have this extra metadata, we need to use it when producing the final video. There are three invocations of ffmpeg. First, we take the original video and convert it into this raw video format, which is just pixel information. There is no headers, no metadata about this file. Then we use some audio filters to process that video as if it was audio. Then we convert the raw video back into a format that is related to the output. So currently we are only informing the size and the rate, but we should also be informing the pixel format, and this pixel format should be coming from the input metadata, like that. And we said that we would also be preserving the bit rate. We have format and codec. Preset, that's interesting, I didn't know that. Duration, yeah, we are going to be looking at this later when we have longer files. Seek, timestamp, metadata, program, target, frames, filter, video options, rate, size, codec. Yeah, we got codec. We have codec, we have pixel format, width and height. We are not being explicit about width and height, are we? Yes, we are. Yes, we are. And I wonder if we use width and height for anything besides the size. Well, we will use. I already know that. Okay, so width and height is under here, under size. And then bit rate is the one that is missing, and frame rate is already here. So we're only missing the bit rate. How do we specify the bit rate? I saw the answer and it jumped away. God damn it. There are plenty of nice things about Visual Studio Code, and the terminal renderer is not the best part of it. It does glitch out sometimes. Anyhow, video bitrate, please use that. I will do that. No problem. Okay, I got all the metadata from the inputs and I passed it along. Codec, pixel format, width and height, bitrate, and frame rate. So now when you bench, QuickTime should be able to play the outputs. As long as it was able to play the inputs, it should be able to play the outputs. Let's see what we changed, commit, and then test. See what we changed, commit, read the chat, and then test. Okay. And npm start. Failed to find the video stream. Awesome. That message we get when the regular expression hasn't matched. So this is the regular expression, and the the line will actually not be logged because it was not a failure in calling ffmpeg. So perhaps what we should be doing is fail to find video stream, new line, interpolate, input metadata text. So at least we have something to go off of when this error occurs. Fail to find input stream. Okay. Let's allow interpolation to happen. At least one output file must be specified. Oh, that's expected. This is the line that did not match. Why would it not match? It starts with stream, bunch of things, video, okay, codec, okay. I don't think I want to have this space here. Will that fix things? No. Then pixel format. Then this. Oh, okay, there may be junk after that. Then bit rate. Then frames per second. And then whatever. Still. Oh, bit rate of 640 is extremely low. Maybe you mean 640K. Do I mean it? Do I mean that? Is that what I mean? Not sure. It was 6040. It was 640. Oh, but it was kilobits per second. It is informing me this information in kilobits per second. So when I use bit rate, it should be saying that in kilobits per second. Okay. And we had a clean exit, which means that this time it worked. So under the video short 4 folder, there is a file, and I hope that QuickTime will be able to open it. And it is. Yay! Is it the best video quality? No. But it's glitchy. I will take it. So second thing on the list, explicit pixel format. Check. In fact, much more than pixel format, we are being explicit about the bitrate as well. Now comes the fun part. We can play around with other formats. Right now, we have just these 2 pixel formats, these 2 audio formats, bunch of sample rates, audio channel counts. I think that the most interesting to play with is the audio filter. So let's add more of these. ffmpeg, filters. I will pass this to pb copy. And drop it here. And in theory, we could use all of these filters, but for the time being, we are interested in filters that take audio as input and produce audio as output. So what we can do is select all of these lines. And these kinds of filters require 2 input streams of audio because it's doing something like a sidechain compression thing. So I will remove these because I am not interested in these kinds of effects. What we are left with is a bunch of effects that do only audio coming in and out. Perfect. So how about this? Now we have a bunch of things we can use. Some of these are probably going to fail, actually. But I want to play with this. And I could just run the program over and over, and I will have multiple outputs to play with. But let's go to task number 4, which is to loop and generate a bunch of outputs all in one call. Let's see what we can reuse. All the input metadata is stuff that we can reuse. Then, this is what we want to change. So this part, I will want to put in the loop. And for the condition of the loop, we have the number of bands. So let's have the number of the band. And you know what? I think I'm gonna, instead of going from 0 up to bands -1, I think I'm gonna go from 1 up to bands, just like that. Because this is going to be the file name on the output. And I think it is nice to have things counting starting from 1 when you're showing this to the user. So this is stuff that I want to happen in the loop. And in fact, this stuff can happen above because this is us converting the input file into raw. But we can reuse that information. We can convert into raw just once. And why is it complaining about the pixel format? Oh, I see. It is complaining about the pixel format because the pixel format is one of the things that we banned. In that case, I think I will just put this in the loop as well, which could be silly if we were outputting the same, if we are choosing the same pixel format over and over. But in most cases, I don't think we will be using the same pixel format, so that should be fine. Yeah, let's look at what we changed, because I don't think it's going to be a lot. We just put a for loop around the program like this. Fun stuff. There is one more thing that we need to change, and that is the file name of the output. Right now it's hard coding the number 1, but it should be bench instead. And with that, because I saved, it already started running actually. Which means that we already have a video 7 folder. And it is bending away, isn't it? Something is odd. It's just like not doing anything. Well, it is going to complain about some filters some of the time. That was expected. We'll have to weed out the filters that fail. Okay, now we are talking. Now we are talking. Yeah, it doesn't like this. See, that's what I'm talking about. This is the glory of data bending when you can do it at scale like that. For whatever reason, it is just hanging some of the time. So I suppose that there is one of these that takes a while. It's probably a slow filter. Is it? But it gets out. It gets it out sometimes. Ah, see? Got out of the thing. It was able to do it. It exited with a clean exit. Awesome. So let's look at the bends we got. The fruits of our labor. It didn't do anything. That one is kind of interesting. It didn't do anything. This is just a green screen. That one, that's what I'm talking about. Oh, it failed, so it left the input and output files there, which could be useful, I guess. You could look into the log, see what went wrong, and redo it. That's kind of similar to the other one, so it would be weird for it to randomly pick the same twice. And again? Okay, that is more like it. It didn't do anything. That is odd. Didn't do anything. Didn't do anything. Okay, I like that one. Now this is the shit. This is why we are doing this. I probably need to start keeping some of this that I like. And in terms of usability, I think it would be polite of us to say what lines were run for what outputs. So let's commit what we have and then do that. So this was simple enough. Let us find where we are outputting to the file, which is here. Well, actually, let's first take this and extract it into a variable that we will call output. Is this variable already taken? It's not. So output is equal to that. We are going to define this name up above. There. And then we will take the output and print that to the file. There you go. Now we are segmenting the file like this. I don't like how I'm having to repeat this append file and this path join and all of that. So I'm going to define an auxiliary function for this that will have to be asynchronous because it is writing to a file. And I'm going to call this log. That name is not taken. Okay. And I will log a message of type string. It will return a promise of void because it doesn't return anything and it is an asynchronous function. And it will do this. And it will take your message and it will append a new line to it, to the file like that, okay? And then what I want is to find every occurrence of append file. There should be only 3. Yes. And then log that. Log dash. And log dash. And for good measure, I will find the end of the loop and I will log an empty line. Okay, so that is optional. Do I need this parenthesis? I don't think so. I think that this binds tighter. null or 1 plus 2. That's 3. So that is nullish coalescing operator 1 plus 2 instead of being nullish coalescing operator 1 plus 2. Am I right? How do I prove this actually? This doesn't prove anything. If I put parentheses around this thing, it doesn't prove anything. Doesn't matter, I guess. The difference is that we don't get the new line. Why am I having such a hard time reasoning about this? I'll just put the damn parentheses there. But the nullish coalescing operator should bind tighter. Anyway, let's look at the logs that we are producing now. Oh, another one failed. It doesn't like pan. But the logs that we were producing are perfectly all right. And it does not like another filter. What is the filter? Format, blah, blah, blah. Okay. I have a feeling that it's not even running, I guess, which is odd. Perhaps what we should do is write a little program that is going to not randomly, but deterministically run through all the filters to find the ones that fail. Perhaps that's easier than just iterating on this. Because this time it's complaining about something else, and I cannot even find the problem here. Okay, yeah, side data. It's just so much information that it's hard to parse. Oh, but that one we already commented out. Get out of here. Why is this log still complaining? Oh, because there is a new log now. Okay, and that one finished actually. 10 new bands. Let's look at the bands produced by our lovely program. This one did very little. This one I can accept. I like how there is a shadow here, and I don't know if you can see this, if the stream makes this any justice, but there is a shadow Leandro here in the middle, and it's kind of red and creepy. I will take it. Didn't do anything. Ah, I like that one. This one we see often. This one I really like. And this one we see really often. And this one is just a little silly. And this one didn't do anything. Most of them are not doing anything. I suppose that these audio filters are too... they don't change the audio that much. They're probably like equalizers that have a band that doesn't do a lot or something of that sort. All right. All right, so I think it's time for us to wrap up. We did do all the 4 things we promised. We fixed the problem with the files being too big. We made the pixel format and bitrate explicit on the outputs so that QuickTime can play the file, or at least we will not be breaking the file in the process. Breaking the file. It's not really breaking, but it becomes unsupported. We experimented with more formats, with more bands, and we did a loop to generate multiple data bands. So I think that that's a good time for us to wrap up. And moving forward, tomorrow I think we will change subjects. So perhaps tomorrow we will come back to the auto mixer and do some audio processing, or we will go to kill the newsletter. I don't know. We'll see. You will have to stick around and figure it out. Or to find out. Anyway, thanks for being here. I really appreciate you all joining me. So thank you, Mage and Arya and Bo and Nod was one for joining me here on the chat. Thank you to everyone else who is watching this. And I see you back here tomorrow. Have a good one. Bye. Thank you for watching the stream, you know how great it has been. Or maybe it sucked, and I am glad that you stuck with me. And soon we'll all be back together for some more coding or talking or chilling. The next time I'll be streaming.